So let's go ahead and get started on our next session. Those who do not know Amir, Amir Abrari is the Innoslate systems engineer at SPEC Innovations. He holds a Bachelor of Science and Master of Science from George Mason University in Systems Engineering Operations Research. He works on a variety of projects. He's been instrumental in our integration of the LLMs, APIs, and artificial intelligence into the Innoslate platform. And over to you.
All right. Good to see everyone again. Today, in this presentation, I want to talk about more like data mesh interoperability, using Innoslate with other tools. In the demonstration that I'm going to follow, I'm going to show Cameo. I'm going to show Innoslate. I would show Jira, but I ran out of the trial. But the same thing applies. Basically, it all kind of applies in the general term of being able to work together. This presentation came up, and this whole thing came up by this information. I've kind of gone over it, but basically, a product of this was when Steve came up to me and it was like, we have a client that's interested in using Innoslate and wants to use Innoslate for their stuff, but they're also required to use Cameo for their model. And we're like, okay, that's fine. And we're like, what could we do to make this process easier where they can use both separately and kind of keep their storage data elsewhere? Now, there's a disclaimer. This is separate from having a data hub. This isn't the data hub approach. Like I know other companies might do that. Our goal was to keep the data as the product and keep the data separate on purpose. Now, if you want to do data synchronization, you're going to be looking into integration, which other tools do provide. But we want to keep these independently separate, but also create some traceability that allows you to link an Innoslate document or entity to a Cameo diagram, for example. So that was kind of the goal. And I know data mesh technology is kind of being pushed a lot on the government side to a point. And we just want to make things flexible. Obviously, why does this matter? We at Innoslate, SPEC Innovations, we promote the idea of staying within the tool in an all-in-one tool, but we don't want to, constrain. If you have the preference to do your modeling in another tool, that is okay. And that was kind of the concept of we can work that way if it's needed. So the term being forced to use a singular product, we don't think it should be any. There should be a lot of freedom to what you want to use. So if you want to use the 3 combined, 1, 2, none, that's kind of like what we want to leave to the consumer, and still kind of maintain that agile traceability, just to have things linked. But again, just a reference link. It's not a data hub approach, and that's by design. So a little bit about how Innoslate's entity URLs work. This was very important. And this was the integral part of why we're able to do this. If you're not aware, Innoslate is completely a web interface platform, which means that the way you get to an Innoslate page is through a web URL link. So each URL link, these are 2 examples, example 1, example 2. Each URL has a very unique identity. Everything in here is unique, but P. P just stands for project. That's about it. Everything else has a very unique notation. Cloud, meaning cloud versus gov versus government cloud, right? If you're on an enterprise server, you're looking at a local host instead of where gov is, where cloud is. So very simple, but everything else is very consistent. In this example, number 1, we are in the training organization in project 849 in the diagrams dashboard action diagram that has the entity ID 171946. That is how we denote Innoslate linking. It allows us to trace things better, allows us to know what kind of project you're in, even without having to look at the header of the project. Comes in very handy in that sense. And that unique identifier is unique everywhere on every single variation, any single version. And it gives us that flexibility to then use each link as a unique personal identifier of what that object is. I'm assuming you can now see, I can just link this to another project and just redirect it and Innoslate when I need to. That was the idea. And that's what we were then aiming to achieve. As a byproduct of that, when I did this initially, I was like, yeah, this is manual. I can one by one link a project if I want, but it's going to take a lot of time to go copy paste URLs. And luckily, we were in a development cycle, and our software engineer was kind enough to, well, Steve told him to, but we were able to sneak in this feature to be able to take entity URLs out. This entity URL now is an attribute that can be exportable. That allows us to get the entity attribute of every single object, making that object traceable to that link. So that then allows us to extract this link. If you have 20,000 objects on this site and you want the link for all 20,000, it just takes one click, create, and you have CSV full of that file. That was the idea. And there's no extra step needed. There's nothing else needed. Now you can go onto your tool, whichever tool you want to use. EA, Sparks, it does not matter. Every standard tool should have a link and a hyperlink, and we use that link to go ahead and create a connection. Now, it's not integration if you're thinking of a data hub, but it at least creates a connection for trace and documentation. That was the goal. And I want to emphasize the goal because if you want to go above and beyond that, that would require a lot more development of a product, and we just weren't in that cycle at that point. So interoperability. Basically, this is a small little tutorial on how you do it. I'm sure we're all familiar with this as a Cameo diagram. All you have to do is right click, go to the specifications. Every element on Cameo has a specification. No matter what they are, they have specifications with their element group, and you can create relations, obviously, on any Cameo file. But the specifications tab is very integral. That'll allow us to do that linkage in the documentation. This is how I was able to add my hyperlinks. There's two real methods to do this. You can do this in the documentation tab of any Cameo element, or in the hyperlinks. That hyperlinks has like that visual that it creates. You see over here, you can have a visual created for you, but you can also do it in the documents tab over here, which is above hyperlinks, is documentation and comments. What was nice and what I did appreciate about how Cameo did their interfacing was when you click it, it allows that link to be clickable, so you can easily redirect to the link that you've linked it to instead of going over the specifications and finding the link and click. And that was the goal. This person wanted to use Cameo actively for diagramming, so we don't want to constrain them. Put the link in their documentation. You can create your documentation in the documents tab and go from there. There's a lot of flexibility with that methodology. And it's kind of just a process model. There's no real constraint to it. And as you see here, once you click that button, and again, you see open that link. Now they redirects you to the entity view of the Innoslate object. It says Cameo on that action diagram, and this is the requirement that is satisfying that action diagram node. And that was the goal. We just want to create that linkage that way. I did find a way. I was thinking, well, what if I want documentation or a report of these linkages on the traceability? I was able to do generic tables on Cameo and be able to do my targeting. You can target what types of elements. As you know, you can do a block, and then you can say, I want to target my blocks, and I want the column documentation or the column hyperlink to show, which I have for. So we even can generate reports of traceability between the two platforms that way. This is very short-term, like very quick solution approach, if you notice. And I've mentioned this many times. Very quick. If you want to use, or even if you want to test how Innoslate works in combination, it's very achievable and doable in a matter of 5-10 minutes to do this linkage. This is what I was talking about with generic tables. You can create your documentation and actually add that as a documentation tab. Now you can have it as the hyperlink, active hyperlink, or you can document this one at a time. Now, I understand it's a manual process to that, but it would definitely help a lot. Now, one thing I did want to mention was in the documentation, I didn't do this manually. I just basically exported this. When I get the CSV file, I got the CSV file that had the name and the URL. All I did was copy paste the two together into here. So yes, there's manual process, but the goal is to create some traceability, and I was able to achieve that. Again, very quickly, very low effort, and keep mentioning that because it truly was, and that was the goal, was let's see what we can do for now as interoperability, and the future, we don't know what holds, right? Yeah, that was the kind of lecture part of things. Now I'm just going to share my screen really quickly, show the two tools together. I know I'm keeping this presentation relatively short. That's just for discussion. If you want to talk, the experience I had, I can go and show other things. But yeah, that is where we're at. Sharing is not, okay, so I'm just going to share my screen. Let's see, I'm on now. Okay. So this is my screen. Over here, Jesus. Oh, okay. Let me hide video panels. Okay. Okay. So now this is a very, very generic model of Cameo. I mean, it's as simple as you can really get. And just a parallel, as you see here, your indicators for URL links are already there. I don't know if I should. But you have your model, and all you have to do is, you can double click this and navigate to the element rather quickly. You can go to the specifications, go to the documentation. Well, this one I don't have documentation for, but you can see here, I can see all my active links right there. And it also notices the type, which is very nice. And I did notice that all my hyperlinks get saved, so you can reuse elements that way. If I already put an Innoslate link in here, that link will still show, but I can still toggle them back and forth or have them as default navigation, so it doesn't even show. I just store it in there. Again, the point is just to store that information there. I know that 8.3 has that documentation table that I'm talking about in this case. We see here, I have my documentation here, and I can still right click change my spelling. But point being, I can still grab this link and navigate to it quickly in that sense. And as I mentioned, I can click this and click this icon as well and still navigate to the next in that way. That active generic table that I showed, this one's actually very helpful, as I mentioned. Just, hey, I'm the engineer working on this. I have some Innoslate links, I have some active hyperlinks and documentation. If I want to get an export from this to see how my two trace to one another, I can always get this export, save it, and go see my export in whatever way I see feasible. See here. And this is, again, very normal, traditional stuff, very doable for everybody. And again, the point is just create some linkage in that sense. I know I mentioned how we're able to generate masked links. I just wanted to show that really quickly. Basically, this is a query of all my requirements, and all I have to do is just click my reports tab, get my basic tabular. Let me get my basic tabular. Can put a file name, number, whatever it's required. But here, all I have to do is include my entity URL. And once I do that, I can just demo and sort by my number. Sure. Once I create that, that allows me to then have a CSV full of my links. And I can go in and import these links to Cameo, Jira. I did this with Jira. Jira could do multiple hyperlinks just like Cameo can, documentation just like Cameo can. And I expect that all entities on, MBSE tools have that specification / repository for you to store information. And we can put that there. I will say, and I know this question is going to come up, is this link static? No. This link will change as your information changes. Your traceabilities within Innoslate, they're still going to have that within these links. So you don't have to ever worry about, do I have to change this link or refine it or whatever it may be. And yeah, see in this case, I generated the summary of what my entities are, but I also got the entity URL if I want to link them to Jira or Cameo or Jama, whatever it may be. Additionally, if you're looking to integrate, if you try to convert between tools, we have import analyzers that are very robust. Document exporter can import 1,000 statements, 200 of them being requirements. We use keywords and just say, hey, look for shall statements, and it'll convert them to requirements and bring them in. There's a lot we can do on the tool, but if you try to go out, combine the two, work together, you're more than welcome to do so. yeah, and that's it. You have some spare time. Thank you.
Good. Okay, so any questions? Totally clear, wasn't it?
It's really simple.
Huh? Listen.
Hello. That is really cool.
Can you elaborate on the static, dynamic linkage? So if I'm associating the hyperlink to the Innoslate element in Cameo, and then something happens where that hyperlink changes, how does Cameo know to grab the?
On the Cameo side, it's static. On the Innoslate side, all your information, no matter what it is, will stay the same under that link.
Okay.
Now technically, if you change projects, you can change the number on there, or if you're trying to switch from a diagram to a document, you can still switch the text within the link. The link is changeable and each link is very, unique. But on the Cameo side, yes, you'd have to do some manual work to.
So in Cameo, you need like a validation script, essentially go through, see if anything's changed, anything's broken.
Sure. Yeah, that could be helpful. I mean, AI is always there. I mean, I didn't include any AI in this. Technically, you can create an import that does that allocation even for you.
Have you guys looked at with Innoslate like a sort of browser GUI, which you're using Jira? So you have, like if I'm in Jira, I'm going through defects or whatever.
Yeah.
Like a defect, and then I can enumerate in model what elements are affected by that.
So I've done some exploration. We have looked into integration with platforms and Jira does make it definitely easier. I know Jira does apps. Apps are very popular with Jira. Confluence being one of them. That's something that I've looked into for us to partner with them and kind of go on there to kind of synchronize our data hubs. It requires obviously extensive timing and allocations of resources. We're just not there yet with time and just path, but.
So let me answer a little bit of that question since I'll talk a little bit more about. So we also use GitHub. We actually have a solid integration two-way with GitHub.
Mm-hmm.
And that's what we use ourselves for our repository. And then similarly have something up for the testing side of it between Selenium, JUnit, and our test center.
Yeah.
And so again, we're around trip capabilities with these things to make sure we do the whole life cycle for software development. But that's what we use currently.
Committing the issues, changing them, the change management of it.
So we've actually been looking, a lot of people ask for Jira. What we just need is we don't have access to Jira, or enough access to Jira to know. And so if there's someone who wants that, we're happy to work with them to develop that connection. And I know somebody from the Navy did do that.
Mm-hmm.
Then you mentioned, I think, JAMA. I was like,
Mm-hmm.
JAMA and potentially doors. Have you guys done anything very dynamic?
I would argue that those are much easier because our export import capability on JAMA and like direct if is so powerful that you can move everything in seconds.
So if I have
migrate.
Yeah.
But I mean, if I'm prepping for deliverables for the government, like we're talking about,
Yes.
and I want one sort of snapshot source of truth for that deliverable, but from a CM rigor standpoint, I'm still using doors.
Yes.
The auto synchronize, I'll make sure everything is interconnected in place nice, and that could be GricIF. I honestly prefer feedback rather than dynamic from the CM standpoint, but it's just
The other part of that is we have, particularly with NetDoors and XGen, actually use hyperlinks the same way.
Mm-hmm.
So again, it has a URL you can connect to, so it makes it a lot easier. You establish a fiber trail.
Because it's a simple process, but sometimes it's a really simple process, but sometimes you don't think about it that way. And we're providing the mass import to help people that want to do that. But we provide this as an alternative until we get to the integration if we have it.
It basically a lot of time. Yeah, I mean, we had started with SCADA, with ANSYS SCADA, right? They had advertised a tool for a traceability wizard, right? It didn't work because the guy really hard on sunset the product. So we ended up just having to deal with these sort of element ID mappings down to the model elements, and then those would be linked into a doors table. So I'm envisioning the same thing, but the chore was just, I mean, we're like 20,000 requirement, then you multiply that by 3 for element IDs. So we're like looking in a cell for element ID, and you know, think of a different tool, looking for the diagram element ID, it's not like a real time, click it, enumerate, right? So
One of the reasons we put all the functionality of the life cycle in Innoslate was to avoid this problem. Because you can spend a lot of time and energy going back and forth between these tools. I'm having a hard time, to be honest, understanding why people want to do that. Just migrate the data and get it over with. And it's pretty quick and easy to do. So I think we waste a lot of time and energy trying to make something that's old function in today's reality.
yeah, it's almost like you start with a DCA.
Right.
For your customer.
Now, if you do need to integrate between, if you're using an enterprise version of Innoslate, you have access to REST APIs. We had an academia use Google Earth and Innoslate together. They used our Post APIs, REST APIs, not Post. Our REST APIs, they built a middleware, Python middleware that once you embed it or once you pick the place, I think it's place on Google Earth, you pin that place, the coordinates, name and number of the thing that you know on your Google Earth, automatically transfer as you click save on Google Earth, transfer to our database under a location with your coordinates, both geo points. So it's possible, right? It would require some third-party coding as is, maybe not to be later on. But the point of it was they operated, integrated, and it's live. That was sync. So it's certainly possible. We've just been too busy on the development of the in-house product.
Yeah.
Right. So that's why.
Thanks.
Yeah, that guy had a lot of success and very, very good job. This is just a master's student that did that. So it's really cool.
Any other questions, comments, thought? What are we missing? Like, what's next? What do you think we should do next with Amir? I'm asking you, what do you think we should do next
For
this?
interoperability. Ideally, we'd have just another, like, just like we have for GitHub, like a subsection that would be like, for example, Jira, just communicate the information both sides. That would be really helpful to kind of satisfy that need. But again, it's kind of like a priority list, right?
Well, like import guidelines, right? For you guys have usage guidelines, you know, the content, right? So, I mean, if you acknowledge today, right, that George is going to be used, you know, Jam's going to be used, all these things will continue to be used for the sunk cost and program schedules and things like that.
Yeah.
So the opportunity to transition won't be always day one, but you at least know what you have to suffer through to do it. So giving people sort of the, you know, guidelines to fix themselves.
Yeah. You don't want to use, we don't want to close the door. If you want to use both, certainly you can. Always recommend coming in because you get all the AI features, all the project management features. But flexibility is.
I was the cost trade-off. The time it's going to take you and how much time you're going to save by doing it that way.
Oh, yeah.
I think if you take a look at even for a large embedded project already going and all that stuff, the cost savings is huge.
Oh, yeah.
Huge. But they have to have the will to do it.
Yeah. The contractor needs to direct the vendor to change.
Exactly. And that's again, it's your customer's decision.
Yeah.
And we're kind of stuck with that, with their knowledge or lack of knowledge of that, you know.
Certainly.
Yeah, we've done a lot of return on investment studies and efforts in this area, and we found that it just doesn't make any sense, right? And what people are doing today.
I believe that.
Yeah. For that. Okay, anything else, guys? Well, thank you, Amir.
Thank you.
Hey, give me plenty of extra time to get set up.
Well, you asked for it.
I need it. I'm gonna need it, I think. So, okay, so. We've already got Innoslate up, good. Oh my God. Did you return? Oh, you did. Okay. Okay.
No, he goes along with some stuff. Yeah.
Yeah, I would say that.
Here's some good ideas.
Pretty cool.
You think I'd have this memorized by now, right?
I can't remember.
That password is just ridiculous. That's what you get for letting the password picker pick your password for you, right? So
Oh, yeah, I think they're not save passwords.
Eva. Okay. So let's see, what is this to talk about? Oh yeah, and mine. It's mine. Okay, so I am shared, right? Do I need to set the sharing?
And you need to share your screen,
I don't think I've shared my screen, have I?
Yeah. But you are good on everything.
What's that?
You should be good on everything else though.
Okay.
Yeah, you're streaming and everything, you just need to share.
Where's
Yeah.
where is Zoom? There we go. So place share. Yeah, we're on custom live streaming, so we're good. And so now escape this. Now.
Yeah, she works on like diet over everything. Yeah,
That's all right.
she just likes going. There we go. Every weekend, it was great. She worked with.
What browser are we using? Chrome? Yeah, okay.
We have a.
Hmm?
There are a bunch of people online.
I'm sorry, what?
There are a bunch of people online.
Oh, good. Okay.
The other session's also still going.
Well, you know, I mean, it's one of those things where.
Yeah, that session's still going. They're all on time.
Minutes started. Change. Next room, come over.
Check, still going, they're going overall.
Ah.
Yeah, that's one. Not what you guys are doing, you know, oh, she's not on the thing. Great.
Yeah.
Oh, one of those.
Yeah. I guess that puts it in perspective.
Yes.
You're still going.
We're good. Tyler's talking long, huh?
Yeah, but
But like, you don't know background.
I don't know, I say stuff.
Still wait a minute or two anyway, so.
They don't know you're that person. How does that work? I mean, she's in the You get one else reading the free flights. Book your employees. You can tell them whether it's available. Working on it. Okay, I've got noon, guys. I'm sorry, 2:00. Let's get started.
You know which session is in government? I forgot to.
So
Personal.
there's going to be a discussion.
Said something.
There's going to be discussion about MBSE and how it's affecting your organization.
Oh,
Yeah, it was a more general, much of probably what we talked about this morning, actually.
Well, you know.
A little bit more than that. So yeah. Okay. So let me tell you about a big aha I had with the problem I think we're running into. I entitled the presentation, Why Software Languages Fail to Support Systems Engineering. And I hope I can prove this thesis. And of course, you guys know me. So you take a look at the history of software and systems engineering languages. And I put languages in quotes on purpose because is a programming language exactly a language in the same sense of what we communicate as people? Not quite so much. It is a higher level language from certainly binary, but it is something that is a little more esoteric and really hard for a lot of people to understand. And you're not just communicating, you're not really communicating to people ideas as much as you're communicating, instructions to a machine to do something. So it's a little different, and that's not quite what we're looking at particularly. And back in the day, I remember there was, particularly in the 70s, we were talking about something called software through pictures. The whole concept was, I'm going to draw pictures and from that produce my software. Okay. Now, we've come a long way with that. And certainly I can talk about that more in a minute, but then sort of the next thing that kind of happened was structured analysis. Okay. And that's particularly where I came into play in the early 80s. I embraced it in like the mid to late 80s. Got Jordan DeMarco's book, looked at the whole real-time extensions thing that was done by Meller and Ward or somebody like that. I forget what those were. Anyway, but those kinds of things and looking at them, and I used data flow diagrams and state transition diagrams. Those were two to work with. And at the time, I had two tools to use for this. One would do the FD, and the other would be using the STD. Now that was partly because we were using still very new technology in the 1980s. You're talking about 84 was when the Macintosh came out. We had several iterations, but by 87 or so, when I was trying to do this, 87, 88, things had just evolved. So there still was limited memory, limited capabilities of the applications. So to actually make both applications work, I'd have to swap out drives even sometimes. So it was kind of funny. And so the problem was the two tools, each one of them had a different database. And so I managed by myself to get those databases out of synchronization. so that talks about some of the problem we had. And again, but it never felt good. I was trying to do survivability analysis with it, particularly as that part of systems engineering. And something was wrong. It was just off, and I never quite knew why. And I'm going to talk about that more in a minute. So another thing that was kind of popular in the 70s and in the 80s was IDEF. And IDEF, which is now ICAM, I guess, is the new definition of it. It used to be integrated definition method. ICAM was the previous one method. I forget what that's another acronym, and I can't even remember what it stands for. But anyway, so that's there. And it's still, by the way, out there. There's a website for IDEF. There's like idef.com. Okay, so it's not dead completely. And as I remember it, it had like 15 different diagram types. So it was a diagramming framework as well as many others that people see today. Unified modeling language, UML, came along in the 90s. Particularly, there were three different notations. I forget the Booch and Grady and Rumbaugh, I think were the three. And I think all three ended up working for IBM, and IBM said, we're not doing three notations, we want one. And they merged it to create UML. So I came along, and that was, again, the idea was I'm going to draw pictures, and I'm going to be able to generate software from my pictures. This has been the goal all the way along here in the software world. In each case, systems engineers tended to pick up these languages or diagramming frameworks and attempt to apply them to systems engineering like I did. I didn't realize that other people were doing this, but everybody did. And it made sense because we didn't have a systems engineering methodology or diagramming framework for systems engineering per se. So again, currently the most popularized systems engineering language is SysML, but it's a profile on UML, right? Means it is a portion of, it's using UML diagrams and adding to those, but not all of the UML set, by the way, right? It used only a portion of it. Okay, so if you look at the world though, as again, I think the reason that systems engineers were so attracted to the software engineering frameworks was they're trying to communicate better with the software developers. That was a big part of the problem. Everybody said software is the problem. By the way, software is not the problem. The people are the problem. But that's an aside. Anyway, so you know, unfortunately, by the time the systems engineering community adopted these languages, the software engineering community was on to the next thing, almost every time. And you can see that. And particularly this graph here shows you that specifically for SysML and UML. This is actually a Google Trends of the Unified Modeling Language. It's very recent. I just did it. I didn't put the date on it, but I did it just before this conference. I've done this about a dozen times, this diagram, over the years, and found the problem. So you can see as it's decaying exponentially in terms of interest out there in the software world, all of a sudden SysML gets invented. Okay, so we're adopting that language which is dying. So now, one of the things that was a big aha for me was I hired some software programmers straight out of Virginia Tech, which is a very top level CS school. Okay, computer science school. And I asked them, well, what UML diagrams did you guys use? And they looked at me and said, what's UML? This was like 2009. So they were already not using it in school. You go talk to any university professor in CS and ask what they're doing with the UML, they'll laugh at you. I've done that at George Mason, by the way, particularly directly asked that question. And so okay, so what's going on here? They basically rejected the idea of software through pictures. The software community basically said, nah, we're not doing that. We're going to use Agile. Now, I like to call Agile hacky. Because it's build a little, test a little, build a little, test a little. I mean, a lot of that, it's very iterative and particularly works very well in a small scale. Okay, pure Agile, the way people meant it to be, where we're really thinking about apps for your phone. Okay, but as you get to bigger and bigger bodies of software, of actual lines of code, you end up not being able to do that. You have to create epics and what is now called scale Agile framework. And so that's a little bit more. And we discovered that ourselves with the development of Innoslate, that we needed to do that well before we ever heard of scale Agile. In fact, well before I believe it was ever even invented. So we were recognizing we were going to need that. There is one pictorial representation that my software developers will accept. It's called a wireframe. And a wireframe and wireframing tools help you develop the user interface and do interactions with the user interface. And you're familiar particularly doing that because Amir has to do the wireframes for us for the software developers. So this is something that, again, I was so surprised when I realized that this was what was going on back in the early 2000s. I said, well, what do we do different? What do we do then? And that's partly why we started thinking in terms of other things. So again, software engineering is like most disciplines. If you think about it, it's mostly deterministic. Ultimately, particularly with software, you end up with ones and zeros, right? It ends up being binary in the computer. Okay, can't be much more deterministic than that, right? In systems engineering, it's all about probabilities. It's stochastic in nature. Why is that? I mean, because we deal with people. People are not deterministic. Neither necessarily is your AI bots, which is another aside. So if you're thinking about how do I model AI, well, how do I model people? Okay, AI should be better in terms of being deterministic than people. Okay, so anyway, that's another interesting idea. So thinking about that, that's why, because it's more abstract, we have to use diagrams to communicate. It really helps us to have a diagramming language that we can really use to do good systems engineering. Okay, so what we need is that framework. How can we use this? How can we create a language that that would be helpful and not made necessarily through these software diagram frameworks? So let's see again why they don't work well for systems engineering. Let's see. Oh, there we go. Okay, so I'm saying yeah. So do software engineering diagram frameworks meet the needs of systems engineers? My answer is no. And let's use SysML as an example. I hate to make it the stalking horse, but it is the current one, so might as well use it. And this is, of course, version 1 I'm talking about right now. So again, you look at the SysML diagram pillars, right? There's structure, there's behavior, there's requirements and parametrics. Okay, not bad. Particularly structure. We do need to understand the structure of the system. I want to know structurally how it's built, whether it's components, subsystems, systems. Again, these are common concepts down to parts, maybe. Okay, and then also I want to be behavior. I got to have a way to understand the functionality. I'm particularly process. Process is critical for human interaction, right? We need a process. We need to know the steps we need to go through. And we want to formalize those steps because sometimes we're working with stuff that you do the steps in the wrong order, somebody dies. Or as I like to say in DoD, the wrong person dies, right? Our guys die, they don't. Okay, anyway, so that's key. Those are great. Now, they added for SysML, from UML, they added this requirements and parametric diagrams. So that was the big things that were the big change from what was already going on in UML. So what's the problem? Well, so let's start with those two added diagrams. The requirements diagram, right? Great if I only had a few requirements. How many requirements do you have in a major system? Tens of thousands, hundreds of thousands, maybe even, depending on what you're doing. If it's something like a nuclear power plant, maybe millions. Okay, you're not going to diagram it. I don't care what you think. You're never going to get that on a diagram. It's just not going to work. It's an impossible task. Okay, and so you've got to think about how are you going to use this. You could use it on little subsets, but that doesn't help me understand my set of requirements at all. So the other diagram is the parametric diagram. That's diagramming equations. How many of you like diagramming sentences in English? When you had to do that in high school, actually high school or even before that, right? All right, how many like that? Nobody, right? Nobody, we hated it. Okay, as a physicist, diagramming my equations is the last thing I want to do. I spent a decade plus learning how to do math properly, right? Very advanced math. Not advanced as his set theory stuff. That was good today, by the way. I did a little set theory, but nothing like you've done this. But so anyway, so anyway, as Mr. Incredible said, math is math. All right, we're Disney, right? We're Disney. It's everybody know Mr. Incredible from The Incredibles. Okay, yeah, both of them, 1 and 2. Okay, yeah, Mr. Incredible. Okay.
The math is math.
Yeah, it was from 2. You're right. Oh, good. Yeah, okay, yeah. I'm talking to somebody who understands. I have grandchildren, so I'm well aware of Mr. Incredible. So, okay. So anyway, so looking at again, the other SysML diagrams are kind of okay individually, but they're really kind of over complex. There's a lot of symbology, and there's a lot of, I call it clutter. Things like the block with the double arrows and stuff like that on there and stuff like that. I know it can have meaning, but usually it's just duplicative information. And you got to know how the lines are drawn, right? The line is drawn a certain way, and the arrowhead is a certain thing, and what does that diamond mean, and what's that fork mean? I mean, there's a lot of stuff to try to understand and to try to communicate. And systems engineers, that's our job. We've got to communicate with all the stakeholders. So again, trying to avoid that. Another good example is the sequence diagram, which again is fine for simple sequences, but as soon as you get into a really complex sequence, particularly dynamically, it fails miserably. It's very hard. You're already getting one pass through the system. It's usually what you're getting with it, and not all the different possibilities that can happen. So again, I abandoned that diagram decades ago because of it. So SysML to any better? I don't think so. Again, the ontology that they developed the language was based on something called kernel. Are you all familiar with that, kernel? How many people knew about kernel before SysML decided it was a good idea? Nobody, right? Nobody ever heard of it. That's because it's a language for designing compilers. What does that have to do with systems engineering? I have no idea. Does anybody have an idea? Have you guys been through the SysML briefs and stuff? Yeah.
I think maybe their thought behind that was integrating their text-based approach to, I guess, diagram generation, the text pool model, or whatever they call
Okay,
it.
let me try to paraphrase what you just said. So it's the you integrating the text tool idea with the particularly they want to do mathematics. They want to do calculations, I think, is really what they were trying to get to. Is that the way?
So I think maybe, and this is based on this little bit that I know about it. With the V2, they're trying to implement some sort of like a text-based, almost like a coder.
Yeah.
Like coding mechanism. So that could be part of what.
Yes, exactly. So they're creating a programming language for diagrams.
Yes.
It is the absolute opposite of what we're trying to do diagrams. Absolutely the worst idea, right? Because we're trying to use diagrams for people to understand what the software does.
I suppose unless
Not the other way around.
unless you're a coder that is tasked with creating these diagrams, and to you it's more efficient to do that.
Yeah,
That
but
might be the use case there.
okay. How many of you are coders? Okay, good. I've been programming since 1971, and I love programming, but that's not systems engineering. Programming is not.
They're trying to express the diagrams and the model, right, with language
Mhm.
being,
Sure.
it's models to code, right? And so that's what they're trying to achieve is that, yeah, you can draw all those diagrams and they can have all that symbology, which is, it's rich and it's there to be expressive, but then to get to sort of like the underlying, meaning of it, more of a mathematical expression, because languages
Sure.
are,
Sure.
software languages
Sure.
are based off of mathematics.
Yep.
Okay.
Yep.
And some set theory. So if I can do my diagrams, but those diagrams and symbology translate into statements and expressions, then you're going from a visual language to a textual language.
Sure.
So I can then export that text or that code, and then share it with another application that can understand the same language,
I understand.
which is kind of part of the idea behind something like XML.
Oh yeah, and that's all good, but again, that's not really hitting what most people are trying to get done in systems engineering, and certainly stakeholders have no interest in that, because much like you made the point, they don't want to see the stupid diagrams. They want to know what the result is. And so again, there's limitations to these things, and we're making it hard for people to do some of the things they're trying to do. We diagram because we want to make it more abstract. not the other way around. So again, it might help us. I've been praying that might help our interoperability problem. I think the jury's out on that, and we'll have to see what happens and how well it works. Anyway, so again, we're still waiting for that to be finalized, right? It's not done yet. They've been promising it to be done for at least 2 years. So what's the alternative? Well, LML, of course. That's why you're here. And so what we've been doing that again, this is a LML v2. I did a presentation on that yesterday. Is basically a result of years of exploring the extensions to version 1, not a new language. Okay, these have all been tested. So this new version of LML is well documented, well tested, well verified that it works. Again, the addition of the interface control diagram gives a diagram type that many people draw, but there's never been a standard for. And interfaces are key to what we do in systems engineering. So we thought that was a critical add. And of course, you can add attributes to enhance it as you need to improve other things. So again, these are things we added to it. And of course, now with the digital delivery of the standard, which is now very unique, gives us a path forward to get us out of the documents world and back into more of the digital and data world. So the bottom line is LML really gives us that complete systems engineering and program management language that's been proven to support a variety of domains. We've used it in almost everything you can think of, and ourselves. And then again, our customers have used it all over the place. And of course, the data-driven approach really gives us time. It will help us move us towards where I think we really need to go next in systems engineering. So again, we want to choose a systems engineering language developed by systems engineers to meet the needs of systems engineers and their stakeholders, not just another diagramming framework. So anyway, that's my thing. Excuse me, sorry, I'm having a hard time. So we have time for questions. Excuse me. Any questions?
So when you say system engineering language,
Mhm.
what do you mean by that? You're talking about the ontology,
Yeah.
and the diagrams behind LML.
Yes,
Okay,
exactly.
but is it represented purely in a diagrammatic way, or is there underlying data representation, like they're trying to do the system element form of code?
So we generate all our diagrams from the data in the database and the rules for review. So that's how we can go from an action diagram to an activity diagram to an zero. We don't care in the tool itself. The language enables that. If we didn't have those relationships and classes well defined, we couldn't do what we're doing. Be very different. And again, we built off of other people who did that same kind of coordinates. MyTech Core had it cradled before that, with them all simultaneously, RDD 100. Many of these people could do what we're doing with that, but it's only because they had a strong language to work with. The difference is we want LML to be open, so we don't have the problem of proprietary languages. We want a language that everybody can use. Because if we don't have that, then we'll never communicate. That's my fear. And when I see what they're doing with System LV2, it's a baby step in that direction, but it's not going to get us where we need to go. They're not worried about cost. They're not worried about schedule. They're not worried about risk. Those are add-ons to them. So what's left? There's performance. That's all they're doing is performance. So they're doing one aspect of what the fundamental 4 things we need to look at for decision makers. That's a problem. It's been a problem for a long time now. I watched somebody for a research project at the CERC talk about how hard they worked to get cost to integrate with the MBSE model. We've been doing that since the beginning with LML. This cost was included as a specific independent variable. So,
I mean, not trying to defend SysML per se, but
that's great.
if you're familiar with BPMN, right?
Yep.
It's modeling, no change.
Yeah.
Okay.
Very familiar with.
For process models. So it has specific notation that's associated with it. It's got all its funky symbology too.
Yep.
But it also has a modeling language underneath it, BPM,
BPL. BPEL is, they've merged them together now. BPMN version 2.0 has the two merged.
has BPEL. Yeah, and the purpose of the BPEL underneath it is that is the codified, the code or the language-based representation equivalent of the diagrams. And the reason they do that is because now you can take that BPEL because it's code and you can execute it, which means you can run simulations of our business processes. That's part of the goal with the SysML too. Is if it's code-based, if you can take your diagrams of your system and then represent them in terms of code, that code can then be, fed into a simulation engine to simulate.
Which is why we're trying to add in the, conjunctions. As to have that being, again, a more English language specific approach to it, to doing that. So it's a very clear language-based approach to doing exactly that. So that's something we feel is missing in LML and we want to add to. And so we are doing work on that. But you're right. But again, I'm not worried about diagrams. I'm talking about the actual, as much as I'm talking about the actual language itself and how it connects to each other and how the things all work together.
Any question?
Okay.
So I don't know if I've asked about too much, Steve, but I'm actually a software engineer. And I'm in this whole system engineering model-based world because I'm doing UML. And I just took it up a level and started doing where I was considering software diagrams at the service level. And someone's like, those are actually systems diagrams. And no one on my team was really doing systems diagrams, even though we've been using model-based in the buzzword for about a year now. So I think they thought it was a good opportunity. One of the big things that I really like getting into the models, and I'm really ignorant about a lot of SysML stuff, but is the idea that I can have a very high level model, black box, and then drill down, get my subservices, get my systems and systems underneath, the whole way down to, from SysML top level, whole way down to UML. It's all linked up. And then at that point, this doesn't work very well, granted, to what you were saying about software for pictures, but there's some type of, you can export this UML models into at least skeleton code, right? Classes, method names, parameters, you have fill in the guts. But you can do that. What I've never had work really well, and what I guess my perfect world for modeling is you have this round tripping, right? Where you can go from your model, generate your code, make your code updates, and then be like, hey, anything that's actually I changed from my model, can we get that back? But so I guess just in general, does LML go down to the UML? The equivalent of the UML level, I guess, trying to do software modeling.
It can go as deep as you want. We were doing a high energy laser test bed analysis where we were down at the software message level. IOs represent the actual software messages. We could actually then also, the conduits would show the actual pipes they're running over, things like that. We had resources as well. There were other things that just are very hard to do, frankly, and anything else.
Yeah, and I'm guessing that because I work for Lockheed, we have requirements to deliver our software models to the government. So we're probably in one of those weird, I saw your graph of how UML isn't really used anymore. We're probably, I guess, in the minority of people that still do a lot of software modeling. So maybe it's a old question, but is LML planning on supporting any type of export code from the model if we're round tripping? Great to update the model.
Certainly it's something we can look at and think about.
JSON, we're doing JSON exports in the next version.
Right.
We have JSON coming, which really simplifies codes a lot more, because XML, we do XML currently, it does the code aviation, but JSON really is much more readable, functional, and you can try to code and go the other way, import the JSON.
Cool.
Yes.
So,
not SysML, but
so I just realized what time it was. Sorry. We need to switch to the next speaker. My gosh. So let me do that now.
Yeah.
So thank you so much. Appreciate it.
Right. Yeah. That's true.
So what room are we in? Okay, thank you. And who on here? Oh, this is the wrong one. I'm in the wrong place. Go back.
class that I ran for state service.
Yeah.
It's actually.
Yeah, there you are. Okay, so it should be ready to go. Okay, Mike. Oh, yeah, yeah. Design.
So let's get started with the next presentation. It's 2:30. I'm sorry to let that one run long. I just suddenly realized what time was. Okay, so Casey Carter is joining us for this session. And I'm trying to get to the right place here. So Casey is a seasoned expert in systems engineering, avionics architecture, and aviation technologies with over 25 years of experience enhancing system performance, modularity, and integration. His expertise includes MBSE, MOSA, and Army Aviation's digital backbone development. He's as a senior technical fellow at PeopleTec. He provides leadership in systems engineering and architecture design. And I'll turn it over to Casey.
Sure thing. Can you guys hear me okay? All right, mic's on. Okay, cool. I did have a co-author in this, Randall Brown. He just had baby number 5 2 weeks ago. He did, his wife did, but he helped me with the AI part. So just a quick agenda, but we'll hit it up here. So Steve gave me a good intro right there, but I'm a propulsion engineer. I went to Virginia Tech, got my degree in turbo machinery. Go Hokies, right? I was there when Mike Vick was the quarterback, so it was like the heyday for the football team. So that was great. His girlfriend actually was a mechanical engineer, so he came to my building often. So I was a mechanical engineer, turbo machinery. My first job out of my master's degree was, hey, you're going to come here and develop propulsion algorithms to detect failures and faults in turbo machineries, jet engines or gas turbine engines for helicopters. So okay, great. So never, ever did that, right? So I jumped in immediately doing avionics integration and system engineering and some application software engineering. So my boss now calls me like his best software engineer. That's not a software engineer, right? And I call myself a licensed troubleshooter. If anybody's watched James Bond, that's a line Connery says in Diamonds Are Forever, right? So I'm not the guy that always comes up and implements the solution, but I'm a good troubleshooter and can get us on a path to solution. So obligatory plug for PeopleTec. They made me put this in there. Medium-sized business. When I started there, we had about 30 employees, been there for 16 years and have grown over the last couple decades. Just had our 20th anniversary a couple weeks ago. All over the country now, but mainly based in Huntsville, Alabama. The part of the company that I work with is primarily for Army Aviation. That's all I've done since I've been there as Army Aviation, multiple platforms. But we've recently adopted digital engineering. Means a lot of different things to a lot of different people, right? But because we support DoD, that DoD 5097 really drove a lot of it. We have a big background in cybersecurity. We've done cybersecurity for 12 or 13 years. Kind of one of the first companies that did that in Huntsville area. Have a huge group in cybersecurity, cloud development, and now we're getting into model-based system engineering. We've talked about, everybody knows the benefits, that's why we're here. But it's presented a lot of challenges in transitioning the people and the culture from doing the old way, right? I intentionally put the old OLDE there because some of it's really old. So challenges in transitioning to MBSE digital engineering. The guidance, Justin and Tyler just talked about the guidance next door. It was really unclear. Like, hey, go do digital engineering. Okay. What do you want us to do? And does it come with any money and training, right? It does not. Does it come with any extra money? It doesn't come with any extra training. The tools and integration. We have accessibility issues. The guys just talked about it next door. We couldn't actually, so we're on the government side, helping support the government side, right? We couldn't actually log into their system. We couldn't share, a Cameo database or Cameo model across Teamwork Cloud because of all these firewalls. We can't internally on our customer site, Redstone Arsenal, multiple agencies. So the project office cannot share the same tool sets, databases with the airworthiness authorities. They have to have their own instantiation of the whole thing. So that's really hard. So that's the cybersecurity constraints, firewalls and that sort of thing. The workforce training, again, it didn't come with any extra training, and it's a huge cultural shift. And then there's talent shortages. We have recs, and this is how this pitch started, right? Presentation started was we have these recs open for model-based system engineers with 20 years of aviation experience. All right, so yeah, that's hard. So there's a shortage of qualified talent, right? Skill gaps in MBSE and digital engineering. The learning curve is, so this is funny, right? I learned this a few years ago. It's actually a shallow learning curve. It's not a steep learning curve, right? Because it's like time's on the bottom and like knowledge is on the vertical axis. So it's like shallow slope means it's really hard to learn, right? It takes a lot of time to learn a little bit. And there's a massive resistance to change. I've worked with a very, very talented, experienced system engineer for 12 or 14 years. And he's got about 30 years of experience, and he's a hardcore INCOSE guy. He hates MBSE, hates it. And it's because he can't figure out the tools, right? He hasn't been trained, and the tools and the versions of the models, instantiations of the system models that he's seen, they're just terrible, right? They're all over the place, and they're not cohesive. It's hard for him to understand what even the requirements are. So this morale and productivity concern, so this is a big deal. And another reason we've kind of set up this program internally is we have at least 1 or 2 legendary 160th SOCOM pilots that have retired from doing, night stalker missions. They are, their names on the wall, they got the stars, they've retired, they've come to our company, supporting the Army, thinking they're going to help build the next generation helicopter, right? They feel useless because they don't know the tools. They don't understand system engineering. They don't understand, they know how to fly a helicopter and what all the capabilities are. They know what they need, but they feel useless. Where before they're like legendary, right? They're on the wall. Now they feel useless. So how do we get past this? Okay, so here's my unicorn thing, right? 20 years experience, system engineer, MBSE, they're like unicorns, right? You're never gonna find them. So where do you start, right? So Justin and Tyler and I all worked together a few years ago, and the way that we had our teams set up was actually the way that we see it fleshing out. Is like you've got the system engineering team, you've got the model-based system engineering team, who are sometimes not system engineers, but they're really good at the tool. And then you have like the architecture team, the avionics, air vehicle people. They're all in these different silos and they're not actually working together. So ideally, you've got a system engineer that knows the tool set, and then it also has got all the experience. So how do you tackle that, right? It's really hard to impart 20 years of experience on a system engineer of like specific tasks, right? It's kind of easy to pick up a tool. I personally had to learn under fire. I get told I had to go off and do a special project. And by the way, the whole thing you're gonna be looking at is in a Cameo model. Like, I think I may have opened Cameo like 4 times. Are you sure I'm the right guy? Yeah, you're the right guy. Go figure it out. Okay. So is it easier to get 20 years experience to like a Cameo Innoslate tool user or train up an SE and give them the experience? Or can you train the SE with all that experience on how to do system engineering and how to do MBSE, right? So that's the approach we took, because we have a plethora of those people that are subject matter experts, but they're not necessarily system engineers, and they're definitely not model-based system engineers, right? And that's the thing, the sticking point that I usually, when I talk to people, and we just put a new, I now work at Blackhawk Helicopter Project Office for Army Aviation. Just put a new subcontractor on contract, and I had to tell them, it's like, hey, MBSE is just a new way or different way to do system engineering. It's not that, we need everything modeled and we're trying to simulate everything. No, we're trying to do system engineering inside a model-based structure. So let's teach the subject matter experts to be system engineers before MBSE. So like the Army aviation community is trying to teach There are people how to be tool users, Cameo users specifically, but they don't understand requirements first, right? They don't understand requirements traceability. They don't understand verification, validation, the system engineering V. They need some sort of a tangible introduction before they go into the tool, right? I don't need people going to the tool and make IVDs and block definition diagrams and whatever. I need them to understand requirements first, right? So I came at Cameo tool from the perspective of, well, I'm really good at traceability. I can follow top level requirement through all the tiers back up through the verification side of the V. So that's where I started. And then I saw all the things that the requirement was allocated to and the flows from those block diagrams all the way through, right? So that was the easiest way for me to learn. Hands-on training. And then I think this is also important, integrated into the daily workflows. Like everybody should be working in the tool, right? And you need inspiration from your leadership. Like, hey, it's system engineering. That's the way we're going to do business, and we're going to do it in the tool sets. Lay the groundwork with the system engineering fundamentals, right? So start with the fundamentals first, so you can have those tangible things. Introduce it gradually. No sense. They've just thrown us. Right now, it's a 2-week, half-a-day course to learn fundamentals of MBSE, right? It's just not useful. Provide the hands-on training, get in the tools, develop things. In that 2-week training trial, they do the hands-on real tools, but it's not like tangible to what the people are actually working on. So give them an example, walk them through. We used to do these model walkthroughs. Is that what we call it? Model walkthroughs. It's really a review. So it's somebody steering a case study through the system model that was delivered to us by an OEM from the top level requirement all the way down through to where it showed up in the architecture. Address the workplace challenges and knowledge gaps, right? Figure out where the gaps are in your integrated product teams and then fill those things in. Ideally, if you're going to set up an integrated product team in IPT, and I wrote another paper on this for another conference, but you have somebody at each step of the V supporting that subsystem development or supporting that system development, right? So that they can all be integrated up and down the system engineering V. Ideally, your system engineer, your MBSE engineer, and your SME in that subsystem is all the same person, but that's never going to happen. So how are we addressing this at PeopleTec specifically, right? So we've got some, and like I said, I'm a mechanical engineer, barely a system engineer, just started learning MBSE, and I'm definitely not an AI person. I've probably doubled the information that I understand about AI by coming to this conference this week, so I appreciate that for sure. I love the conversation about the actors or the agents with the requirements development yesterday. That was fantastic. That's exactly what I would envision using some of the AI for system engineering. But to address these challenges, we have used AI to do plane side maintenance. So part of our company does Army aviation maintenance, specifically for the 160th SOCOM aircrafts too. And they've used AI. They created a chatbot that's learned all the information from the maintenance manuals, from the performance specifications. It's in a closed environment, so it doesn't go out and learn any new information. And you can chat it up, say, hey, I've got this oil leak here. What do you think my problem is, right? And it's mined through all the data. It's learned the tech manuals. So it's now you have a smart assistant to help you do maintenance with, right? And it tells you what toolkit you got to use, where you got to go. Next thing to do is tie into some augmented reality to figure out, okay, that's the thing I got to replace on the aircraft, and here's the tools I need to do it. Personalized training. So we're going to adapt that personalized training to MBSE. So where we envision this, and the next chart has some instantiations of it. I'd love to get feedback on this too. Where it's most helpful is people are just afraid to get into the tool, right? They don't know where to start or how to get to where they need to go. So if we can have the ability to ask an AI agent that lives on top of a specific Cameo model, system model, because that's what we have to use is Cameo. Hey, tell me where I can go to get requirements on my auxiliary power unit, right? That's all I really want to look for. Instead of mining through this, I don't know, how many project usages you think we have in the containment tree? 60 project usages in the containment tree. Where are my subsystem requirements for the auxiliary power unit? Okay, they're right here. Here's the requirements table. That's where I want to start, right? Smart things like that to find things instead of, having to use the search function in the tool. Personalized training agent is really, really helpful. Learn by doing. AI guided workflows. Again, traceability is a great place to start with a workflow, right? Here's the requirement that your team owns in the top level specification. My workflow now is going through the subsystem specification, the component specification, to the configuration item, all the way back up to the verification. Show me that workflow of traceability, right? Smart coaching, again, kind of like the personalized training, contextual recommendations during modeling, fostering intuitive skill growth, and then the knowledge retention, right? So this is where you can also impart information into the AI to help better the model and provide that feedback to the model. So the couple of capabilities that we see, like I said, guided model navigation is a big one. Text assisting well, and then to me, vice versa. Like if I can get, I know there's scripting languages that can do this, especially for like top level specifications, but we, on Army Aviation side specifically, we get models from the OEMs that have multiple different historical document-based things that are shoved into the model, and the information is all over the place, right? So interface control document tells you about data flows between different components, right? Whether if it's an Ethernet message or if it's a fuel flow or whatever, where do you find that information and how do I get to it, right? And how do I represent it? Because a lot of these people that are really good system engineers, they're really good at looking at PDF documents, right? And even the people that are not system engineers but are subject matter experts, they're really good at looking at documents. This doesn't look like a document. It took me the longest time to describe just the behavioral modeling to somebody that's used to looking at wiring diagrams. That's what so I had to contextualize what that architecture was as a wiring diagram to him to show you, hey, these are the flows between these two things. Oh, so that's like this pin going to this on this connector, going to that pin on that connector. It's like, absolutely, right? So contextualize those things. So learn the characteristics of the person that you're training too, right? From an AI perspective. Document-based traceability, kind of going to what I was just mentioning. Requirements test alignment. Can we automatically test things in the model before going to any type of lab-based thing, right? Absolutely, you should be able to do that. Whether we can get some sort of airworthiness credit for it, that's debatable. But I'll skip the model quality assistant, right? I didn't know that quality check that was mentioned this morning about just the quality of the requirements. I had no idea that was in there, right? That's fascinating from Innoslate perspective. We have a lot of technical performance measures. One of our OEMs had about 40 TPMs to understand the modularity and openness of their architecture in the model. So they were able to commit an architecture to the model and instantaneously get a score from these TPMs to define the mostness of that architecture, which I thought was fascinating. But you can improve that with an AI tool, right? One of the big things that I foresee us, and I foot stomp this capability with MBSE a lot, and then AI can help us amplify it as well, is change impact assessment. So once you have a completed architecture, especially from like a software certification standpoint, you always want to know, you have to know, right, from a DO 178, FAA, DER perspective, what changed, right? So even if you change one line of code, you have to trace that one line of code all the way back up to your top level requirement specification to show what changed, what didn't change. So if you have a complete model, and this is where the AI can come in from a completeness perspective, say, hey, what's complete, what's not complete? Am I missing an interaction? Did I not model this requirement from a data flow perspective and I need to model it? If I change one component of my architecture, or I add one component of my architecture, what's the impact from any of the data flows, from heat consumption, from electrical load consumption, from a weight perspective, all those swap things, right? And then what other requirements does that touch? Change impact assessment is the biggest thing I think MBSE will give us. You can get an instantaneous change impact assessment through MBSE, where before it would take you, even with a doors linked database, you only get the requirements perspective. Now you have to go back to all your documentation to see what the actual change impact is. So that's a massive one. Digital soldier feedback, you can simulate an operator, right? And make sure that you have the capabilities defined correctly in your model. And again, you can use those SMEs to train those digital soldiers, right? That'd be a fantastic thing, because now you have a fresh perspective on a requirement, right? From instead of just being, hey, I'm a test engineer and I know how to test, I know what a good test requirement looks like, or I'm a system engineer, system requirements manager, I know what a good requirement looks like. Well, now you put a subject matter expert bot in there and it says, hey, operationally speaking, this requirement sucks, right? That gives you that qualitative feedback. And then risk assessments, again, like the change impact assessment, risk assessments can be a big deal. So if we get time here, we'll have time. Q&A, any of these gaps or anything that I didn't think of that you guys would think of that we haven't picked up earlier this week. Love some feedback here. So conclusions, what we're doing, AI training solutions, help us transition our subject matter expert workforce into system engineering and adopting MBSE. Intelligent training tools will help enable that real time. They can enhance the MBSE analysis. Definitely, I don't know why I thought I was alone in this, but coming to this conference, I was definitely not alone in this, right? Having AI sitting on top of the models and helping, at least from a completeness standpoint, what's complete and what's not complete. And then once it is complete, where my biggest impacts are. AI-enabled tools to improve the system level modeling. These are complex systems, right? I think I asked the question yesterday, like, hey, if you at least were able to use AI to define the top level subsystems or top level system requirements, how do we go to that next level down, right? And then leveraging AI and MBSE together. Like I said, we are building our AI experience, and we have enough system engineering and model-based system engineering in-house usage to merge those two things together. So that's where we're taking. Questions?
Usual last person, we have till 4 o'clock. I'm sorry, till 3 o'clock. So you go. Okay.
I like the integration of the AI with tool, but the thing I liked the most was what you called it at the end there, the intelligent training assistance. Or
Yeah.
whatever. You know,
Yep.
Because what you're doing is you kind of covered two sides there. One is that you've got different use cases across the engineering bee, not all of them, but some, right? Which is like what Mario's presentation was about yesterday. We had the engineering bee for the Marine Corps. It's simply like, yeah, we're going to build, sort of an agent for each step of the bee.
Absolutely.
But that's not really just one agent. It's really a collection of agents that supports that bee or community. So it's communities of communities, right? And they'll get complicated over time. But the part that's most important is that you could have all of that and it could be amazing, but you have the intelligent training I was looking for it there to help kind of like remove or lower the barrier of entry.
Right.
Get over that fear factor. That's part of the fear of AI.
Yep.
Or the fear of the tools. Like I'm fearful of something I don't understand. So I'm going to resist, it's like pulling teeth to try to get people to get into the tool or to use it.
Absolutely.
So they could realize that the AI will help guide them through it, help them find stuff. They don't even necessarily have to know how to use the containment tree. I mean, it's good if they do, but if they can just say, look, I'm looking for X. That's like talking to ChatGPT.
Yeah.
Right? So I'm looking for X. Where is it? You find it. I don't want to have to sift through it. And it could be like in 5 different places, and it will tell you each one. So then you can decide, those are the ones I want to go to, or in what order you want to go visit those locations within the model. So, I like that. You're sort of trying to make it's like the friendly side of AI to help ease people's fears and kind of get them hooked. Because once they can start, I think once they can start to see that they can get in there and they can do things with it, and it's not as scary, it's not as painful, and it's not as difficult, you know, like trying to climb a mountain or something, then.
It was
Once
like,
they get in there,
we actually had people that were so violent against the tools that they exported the requirements out of Cameo and then imported them to an Access database so that they can,
so they can manipulate it.
they manipulate and find the traceability, right? Because they were so fearful of the tool, right?
Yeah.
And it's like, we did take a baby step between, and so in the community that I was working in, the same thing happened with doors, right? We actually were generating requirements from doors into PDFs, right? But we were only ever tasked to review the PDF document. Nobody was ever in doors looking at traceability. So as a result, now we've jumped not from like doors traceability and modeling to like a Cameo architecture. We just went from a document right into an MBSE model. And that was like you said, it's a mountain. So
Yeah.
people needed the baby steps to get there.
Yeah.
So now that we're on the mountain, help us like back down to like Camp 4, you know?
Awesome.
It's so powerful, it scares you.
Yeah.
Yeah.
Right. Yep. I think the hard part will be to like, can you get something deployed on a government system
Yeah.
where that model lives? Or am I gonna have to put it behind some sort of firewall, right?
Especially the higher you get.
Yeah.
So my question was gonna be on the tools that you're using. Are all of these wish lists or are some of them built and what tools are you using?
This is our entry wish list.
Okay,
Yep. And so we're actually, so this was our initial hash at the capabilities we needed. And then we're gonna prioritize it when we're actually opening up next couple of weeks to the broader company and see if they have additional capabilities and we'll prioritize the things. Right.
Okay.
Yeah.
I can ask you this later, but, let's ask this now. Was this gonna be part of the, I guess like a DE, like a DE sort of factory or whatever, but you have like your own organic DE capability, because I know RTC uses PeopleTec, I guess,
Right.
for that, but, so is that part of that, or is this a separate? item?
This is separate. So this would be like under IRAD.
The questions, comments?
Hopefully Randall can come back next year and tell us what we actually did. So he's a smart AI.
Yeah.
Cool.
Hey,
Thanks, guys.
we have a break, from, 3 o'clock to 3:30. And we'll sit there, we start again at 3:30. The next session will be a plenary session in here, which is good because apparently the system over next door died. The Zoom link or something couldn't recover.
Essentially, the computer just bombed. You can't really open Zoom, even with the open Zoom, like camera doesn't work when you click the camera button, it crashes. So something's going on with the operating system. I'm gonna talk to you offline about options, either here or in there.
We're gonna hear.
You don't wanna do in the night.
Oh. Sounds pretty good. Doesn't matter.
Yeah.
What it does, I think that sounds good. Okay, Dimer, everybody? Okay, cool. We'll make that an executive decision.
Well, it's like, they have the table, it's like a U now, it's a whole, I mean,